And we looked at, well, if we did stuff like this, you don't have to write this down. I gave you that. What does that do to the graph? What does the 2 do? It goes up 2, right? Is that what you said? Oh, you meant the exponent 2. I should use a different number. Fair enough. So it moves the graph up 2. And if I put a 2 inside with the x, which way does it move it? You can just say left or right. Moves it side to side, right? So these values we learned were called h and k. And this little formula right here, don't worry about that one. Same formula. Is something, well, we're going to add to it, but the end formula is something you're going to want in a study guide, all right? So we're going to look at what all these things do. So what the h inside with the x, just like this 2 right here, moves it side to side. The k, which is outside of the function, this 2 right here, moves it up and down, okay? H moves it left to right, we call it a horizontal translation. K moves it up and down, we call it a vertical translation. Those things right there. So we're going to practice looking at these and determining what is happening to the graph. So if we have y is equal to f of x, just some general function, we don't know what it is, we don't care what it is. And I say we change it to y is equal to f of x minus 3. Okay. First of all, have we gone left, right, or up or down? We've gone right. We haven't gone up and down, right? Because our h value is what? What is our h value? 3. It's what makes the inside 0. So h value is 3, and since it's positive, if h is positive, it moves the graph right. So this is right 3 units. What about B? What is the 4, H or K? K. So have we gone up or down? Up 4 units because it's positive. I'm just say up 4. All right, C. What's wrong with the way C is written? Thank you. What do I not like about the way C is written? The 1 is on the wrong side. We always want it to be y equals. We want it to match this equation. Y equals blah, 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 blah. Okay? So move the 1 over. Now, what's our K value? 1. Which means we went up 1. What's our H value? Negative 10, which means we went down. Left. H is side to side, K is up and down. Is that okay? All right, it's just taking what we learned about quadratics, absolute value, all that kind of stuff, and now we're applying it to f of x, which is any function. These rules apply to any function in the world. Okay? And you'll see later on when we do trig functions and stuff, you can move those graphs around as well. All right. Let's just do these quick ones here. Okay, now we're going to move points. So we have a point 2, -3, and that is on y is equal to f of x. And then mathematically, they say, state the coordinates of the image of this point under the following transformations. All they're saying is where'd the point move to if you do this. Okay, that's all they're saying. So what's wrong with the way this is written? Y plus 8 equals f of x. What do I want? Y equals. So move the 8 over. Okay, what is that 8? H or K? K. And it's negative, so what does that mean? Down 8, right? Okay. If you're going up or down, do you affect the X or the Y value? The Y value, right? So if we start at this point, which one is X and which one is Y? 2 is X and Y is -3. So this K only affects the -3. And we'll do it graphically and then we'll do it algebraically. So if I'm sitting at -3, well, it's a bad drawing, whatever. If I'm sitting at -3 and I go down 8, where do I end up other than on this guy's head? What's the Y value of that point there? -11. Does everybody agree with that? So the new point is 2, -11, because we didn't move it side to side. That's 18. I don't know why I wrote 18. Sorry, there you go. -11. All right. Let's do this one. What is my H value? What is my K value? What's H? 7, positive 7. So that means we went which way? Right or left? Right. And K is 5, so we went up. Okay, we'll do it graphically, and then I'm going to give you the equations here in a sec. So let's do it graphically. We're at -3, 2. That's where we start at. 2, -3. We go 7 units to the right. So I move this 7 units to the right. Where do I end up? 9. 2 plus 7 is 9. So I'm going to be at 9. And then from this point, I go 5 units up. So I go from -3, 5 units up, 3 plus 2 more. So I really wrote this 9 in a bad spot. So I end up, we'll just call it right there, which is 2 and 9. That is my new point. Does that make sense to people? We went boom, 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 and then we went up. So the new coordinates are 2. No, they're not. X comes first. It's 9 and 2. There we go. Now, that's graphically, you can do it and you can kind of see it. There is a formula that will build as we move through this. And the formula is the new coordinates are the X value plus H, okay? And the Y value plus K. So if you think about it, this one, the new coordinate is going to be -3, the original Y value, plus whatever K is. K was -8. So -3 plus -8 is -11. And this one, H is 7, so 2 is the X, plus your H value, which is 7, gives me 9. And the K, or the Y value, -3 plus your K, which is 5. -3 plus 5 gives you +2. Okay? So I would have that formula written down on my study guide too, although we're going to add stuff to it. All right, is that it? Any questions about that? Make sense? Okay. All right. Okay, write the equation of the image. All right. So what this is asking is to write your formula like this. like y is equal to f of x plus k or f of x minus h. So our general formula, again, we're going to build upon it, but be good to have on your sheet right now, is this. Y is equal to f of x minus h plus k. That kind of is the general, applies to all functions. We just have to figure out what h and k are. So in the first one, it says we do a horizontal translation of 5 units left. So is that h or k? That's h. And we went left. So is h positive or negative? Negative. So our h value is -5. If I don't say anything about going up or down, the vertical translation, what is k? 0. Okay. All you do is you plug these two things into this formula here. So then we just represent that as going f of x. Now, if it's -5, x minus a negative is positive. So it's f of x plus 5. And look, you could go plus 0. Nobody ever would, right? They would just write f of x plus 5. Okay? Translation of 3 units up. H or K? K. And K is positive, right? Because we went up. What's H if we don't do any horizontal stuff? 0. You don't have to write that in the question. I'm just doing it for teaching purposes. So the formula is f of x. You could write -0 if you wanted, but I'm not going to. Just put f of x plus your k value, which is 3. So this means you've gone 3 units up. Last one, m units right, p units down. So it's my h value, m, and it's positive m because we went to the right. What is my k value? -p, because we went down. So in the formula, that is f of x minus m with a minus p on the outside. Okay? All right, we're doing 1, 2, 3, and 4, but not C on 4. Please. Okay. Here's our original graph. Here is what we have done. So is that an H or a K value? The 2. H. And what is the H value? Positive or -2? +2, which means we did what? Yeah. So that means you move the whole graph 2 units to the right. So just take the key points and count over 1, 2, this 1, 2. So there's your new graph. That's it. Okay, B. What do we want to do first? Move over the 2. So we get f of x plus 3 minus 2. So what have we done? What movements have we done? So we went left, how many? So left 3. So our h value is -3. And we went up or down? Down 2, so our k value is -2. All right, so then you just move each point 3 units to the left and 2 units down. 1, 2, 3, 1, 2. Well, it's a bad straight line. And there's the graph. So same stuff, it's probably a little easier with the graph too. You just move your points and redraw the graph, and that's it. H moves it left, right, K moves it up and down. Okay, we're just taking what we learned in the last chapter and just expanding it a tiny little bit. I'll give you 5 minutes to do questions 6 and 7, which is just moving graphs around, and then we will move on to the next lesson. Okay, page 73, you guys, or everyone. Just a continuation of what we've been doing. We've got our basic formula here. Y is equal to f of x minus h plus k. K moves it up, down. H moves it left, right. We're just looking at slightly more complex formulas now. So they want you in these questions here to explain what sort of transformation you've done. So the original graph, y is equal to x to the power of 4. We changed it to y is equal to x to the power of 4 plus 3. So is that plus 3 an h or a k value? K value. So what have we done? We went up 3. That's it. What about the next one? We went from 6x minus 3 to 6 bracket x minus 1 bracket minus 3. So what have we added in? What has changed? Yeah, is that an h or a k value? That's an h because it's tied up with the x. So our h value is 1, which means we went right. All right, what about C? Couple changes here. What's my h? What's my k? What is my h and what is my k value? What's h? 6. What's k? 2. So we went right 6 and up 2. And last one, D, 1 over root x. We changed it to 1 over root x plus 1. H or k? H, because it's inside the radical sign. Okay? If it was a k value, it would be out here like that. Plus 1 out here. Okay? So h value, positive or negative 1? Negative 1, so we went left. Okay. All right. So when they ask you to write the replacements, blah, 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 give the new equation of the image, basically saying, after you do the transformation or the translation, what is the new equation? Now, remember, this is our basic equation. You're trying to figure out what h and k are. So here's our function. We don't worry about that right now. All we're worried about is this. Horizontal translation, 3 units to the right. So is that an h or a k? H. So that means if we put it into this formula, we're going to get f of x minus 3. There is no k value, so it's 0, so we don't have to write it. And then we don't want it written like this. We want it because we actually know what the form or the function is. We want it in terms of x squared. So anything in brackets goes where? In for x. So this function then becomes x minus 3 all squared like that. Don't expand it, just leave it like that. Okay. Y is equal to 10 to the power of x after a vertical translation 2 units up. 2 units up is what value? K. So that means our general formula will be f of x, because h is 0, plus 2. So what does this 10 to the power of x become? If we move it up 2 units. Remember, y is the same as f of x, right? So I don't have to replace anything inside the x. So it's just 10 to the x plus 2 on the outside. That's an exponential function, which we look at in the next unit, which is next week. And last, or not quite the last one, but root x, horizontal translation, 4 units to the left. So that is an h value that has a value of -4. Vertical translation, 3 units down, which is a k value of -3. Which means our general formula, you don't have to write the general formula every time. I'm just kind of trying to tie it together for you. So that's going to be x plus 4, f of x plus 4 minus 3. And then we want to write that in terms of the radical root x. Whatever's in brackets goes in for x. And then the -3 just kind of sits on the outside. So this becomes y is equal to root x plus 4, tack on a -3, and that's it. Okay. All right. Just a couple more examples, and then this lesson is over. All right, now we're going to do it with graphs. So we can do it with functions and words. Now we want to look at graphs and say, okay, what have we done? What is the new equation? So here's our graph. We're moving from the thin to the thick one here. It's an absolute value graph. Y is equal to absolute value of x. What have we done to go from here? Now just pick, easiest point is the vertex on a graph like this. You just have to pick one point. To go from this point to that point, what have we done? How many down did we go? 4. How many right did we go? 2. So we went down 4, right 2. So that means if we went down 4, our k value is -4. And if we went to the right 2, what's our h value? 2. So now we have to write the equation. So let's try it without doing the f of x, just using the absolute value. So the equation of this new graph right here, so the h value goes inside the absolute value, right? So we're going to write x minus 2 absolute valued, tack on a -4 on the outside. Is that okay? Yes? There's silence out there. All right, next one. Now, this is a weird graph. We'll look at these later on in the course. Okay, sort of. Mostly in calculus though. But it's two parts to it. So there's this part and this part. And we're moving to the thick. So just move one part of it. Let's take this point right here, and it's going to move to that point right there. What have we done? In words, what have we done? One right, and how many up? Two. Boom. So h is equal to 1, because we want 1 right. K is equal to positive 2. And our function is 1 over x. Where does h go? What does it sit beside? X or y? It sits beside the x, right? So we're going to go 1 over x minus 1. And then the k sits on the outside, plus 2. All right, 2 more examples, and we're done. C, what have we done? Thin one, to this one. What have we done? Just went down 4. There's no right or left shift. So k is negative 4. They just tell us the function is f of x. So we're just going to write f of x minus 4. They don't actually give us a specific function. And D. Starting there. What's our h? Negative 3. And our k is plus 4. And again, it's just a general f of x. So it's y is equal to f of x plus 3 plus 4. So you can kind of start to see, hopefully, it's going to sound corny, but sort of the power of this. Because now, if you know the basic absolute value graph, and I just gave you this, looking at this, if that wasn't there, you know how to figure out the formula for that, right? You just know, well, I took the original and I shifted it down 4 units and over 2 units. And once you have the formula, then you can do lots of different things without having the graph, right? And then that's where calculus kind of kicks in. If you're looking at velocities, accelerations, and stuff, in physics 11, so you guys haven't taken physics 12 yet, if you're taking it. Do you remember in physics 11 when you're doing acceleration and you draw a line on the graph and you measure the slope? You guys remember doing that? Well, that's completely inaccurate, right? Because everybody's going to draw it slightly differently. But calculus allows you, if you have a formula, to calculate it accurately and get an actual number that is the right answer. Okay, so having the formula is very important. It's easy to generate a graph because you usually get data that you can plot and generate a graph. And so then if you can generate a formula out of that, you can do a whole bunch of different things with that. All right. Questions 1, 2, 4, please. Lesson 2 over. Okay. Here's our graph. X squared minus 10x plus 25. All right. Parabola that opens up. If I change it to y is equal to negative f of x. So in other words, I do this. Don't do that. Go away. Negative what is going to happen to the graph? What does a negative do for a parabola? Causes it to open down, flip upside down. So the graph basically just flips upside down like that. Okay, you've seen that in Math 11. You've seen it in this class. Just causes the parabola to open down. What if we do it to this x cubed minus 8? Here's the graph of x cubed minus 8. Here, let me pull up Desmos. There it is right there. If I put a negative in front, which is not going to work. Oh, come on. Okay, what do you think happens if I put a negative in front? It's going to flip it again. So essentially, if I write negative x cubed minus 8, this graph is going to flip this way. So this negative 8, you can see if you multiply that in, you're going to get negative x cubed plus 8 is going to flip up to positive 8. And then the graph looks like that. So it doesn't matter what graph or what function you're dealing with. If you write negative f of x, it flips it upside down. Okay? So on the bottom one, it's already opening down. I change it to negative f of x. What happens to it? If it's opening down right now and I put a negative in front of it, what should it do? Flip it. So this point right here is going to flip down to there. And it will open up. Okay. These are called reflections, right? So, right here. How does the graph of y is equal to negative f of x compare to the graph of y is equal to f of x? We say it is a reflection. Now here's the math terminology. You can say about, over, or across the x-axis. I.e., only the y values change. You only change the y values. This y, which is at positive 2, is becoming negative 2. And the points that stay the same are the ones that have a y value of 0. Okay? What do we call those points when the y value is 0? What line do they intersect? What line is that? The x-axis. The x-intercepts don't change. So when y is equal to 0, points don't move. That says, it looks like pants. That actually says points. There's an O and an I in there. Don't move. Fancy way of saying that is they are invariant. They don't change. All right, and these are the x-intercepts. The x-intercepts do not change. And if you look at the graph up here, and I didn't draw it, great. X-intercept right there does not change. It is invariant. Okay, so When you have a negative in front of, in front of the function, it changes all the y values. It flips the graph over or about or across. You can say any one of those, it doesn't matter, I don't care. The x-axis is the line you're going over, okay, or around. Only the y values change, x values don't change, and the x-intercepts, or when y is equal to 0, don't move or are invariant. Okay? Flip the page, please. So, what if we put a negative into the x? F of negative x. What values do you think are going to change? The x values, all right? So this graph, x is equal to 5. If we do f of negative x, it will flip over to negative 5 and open up like that. And algebraically, you can show that because whatever's in brackets goes in for all your x's. So you don't have to write this down, but this is just the algebra behind it. You will get this, which then becomes this. And then when you factor it, what multiplies to 25 and adds to 10? 5 and 5. So it turns into x plus 5, x plus 5, which is the same as x plus 5 all squared. Which, you remember from the lessons we just did, what does this positive 5 represent? What letter? H, and it's negative 5, so we went 5 units to the left, and there you go. Okay? So, if I do f of negative x on this graph, what's the graph going to do? Values become negative. So if we are at positive 2, where does that value go to? Negative 2. So that point will flip to there. What about this point right here? What's the x value at this point, the y-intercept? 0. Is it going to change? Because what's negative 0? Still 0, right? So the graph just flips over the x or the y-axis. That is a really bad sketch. Okay. So, in words, mathematicians always like to do the words. How does the graph of y is equal to f of negative x compare to the graph of y is equal to f of x? So we would say it is a reflection about, over, or across what axis? What axis are we going across? The y-axis. The y-axis, i.e. x values become negative. And if they're already negative, then they become positive. You just put a negative in front of whatever the x value is, and that's your new point. You have invariant points, i.e. the ones that don't change. What points don't change? What point didn't change on this graph? The y-intercept. That's what x is 0. At y-intercept, which is when x is 0. How's that? Is that okay? So if the negative is outside, if it's out there, You change all the y values. If it's inside of the x, it's just like screaming at you to say, change all the x values to negatives. If there's already negatives that become positive. Is that okay? Going once, going twice? Boom. All right. This we've already done. We did this yesterday. Normally, I would say we did this last unit, but last unit was yesterday. Okay. What does this represent? Inverse, right? What do you do when you're sketching the inverse? Switch x and y. So I'm not going to do this page. I'm just reminding you. This is an inverse switch x, y values. That is a transformation because you're changing the way the graph looks. Okay. But I'm not going to go through that because we just did it yesterday. So we're going to go to page, I would say 93. We're going to go to page 83, right there. This is the last bit. Okay, we're going to practice this on a graph. Not the best graphs, but it's a little blurry. You can do this. Okay. Here's our original graph. What have we done? Where's the negative? In front or with the x? In front. So what values is it changing? The y values. Okay, so it's just going to flip the y values. What values do not change? What are the key points that don't change? X-intercepts. So this point right here, this point, and this point, because y is 0, you can see it, they've labeled the points. You can go 0 times -1, that doesn't change anything. So those points stay the same. The rest of it, you only change the y values. So if this y value is at +6, where does it go to? -6, so just move down to there. Draw the line. That one moves to -6. Connect. I connect them in order, otherwise it can get confusing. That's at 4, so it moves to -4. That one stays the same, so we can connect that. -3, so it goes to +3, and then connects to that. So the blue graph there is the reflection over the x-axis. All right. Next one. F of -x. What kind of change is that? Changing all the x values, right? We're going to go across the y. So you just take all the x values and put a negative in front of them. What values will not change or are invariant? Y-intercept, yeah. So just that one point right there. All right. -5 becomes +5. This is where it gets confusing. -4 becomes +4. 2, 4 becomes -3. 7 becomes -7. And 9. There we go. I'll give you better graphs than this. This graph is kind of blurry and whatnot. But you can see the graph has just been taken. okay? You guys want to try the next one? What is that one? That's an inverse, right? X is equal to f of y. So let's get the inverse of that. That's going to be ugly. See if I can do it right. There's the inverse of that graph. Pretty funky looking. All right. We okay with that? As long as you know what the negatives mean and you recognize that when it's an inverse, you're just changing either the x or the y values. Okay, last question for today. The graph in the thick line is a reflection of the graph drawn in the thin line, blah, blah, blah. It's saying, what have you done? So we're going from thin to thick. Okay. What have we done in the first one? Have we just check it kind of in your head. Just go, okay. Did we flip over the x-axis? Did we go like this? Boom. If I took the thin one and I flipped it over the x-axis, would I get this thick line? Right? Because this point here would move down to here, and it doesn't match. So it's not that. Did we flip over the y-axis? Well, that would mean this point goes to that point, which doesn't match. So what's the only thing that's left? Inverse. So it's an inverse. The first one is an inverse. So this is an inverse. So we can just say f to the minus 1 of x. Because they don't give us the actual function. They just say it's f of x. All right. Next one. This point did go to this point. So did I change x values or y values in that one? X values, right? This x was at 1, became negative 1. So if I'm changing x values, it's f of negative x, right? It's a flip. You could say a flip as well. It's a flip over the y-axis, or a reflection about the y-axis, or over the y-axis, or across the y-axis. Final one. We've gone, this point here was at 1, and it didn't go to negative 1. It went to, the y value changed from positive 3 to negative 3. So we changed the y values, right? So that is a reflection in the x-axis where you put the negative in front of the whole function. I would write those 3 things down on your sheet. Basically, when you have negative there, that is a flip over x-axis, or change the y values, and this is a flip over the y-axis. change x values. And again, we're going to build this whole formula up into a master formula. Questions are 1 to 6 and 11 and 12. That is lesson number 3. Fini. That is me, Fini, for the day. Well, not really, because I have to do this all again.